Let's start recording. Okay. So we at the end I gave you a problem and told you that all of the 6 basically transformations exist, and you see that all of them exist. So what I did last night, in fact I did it honestly والله اليوم الفجر يعني I was too sleepy last night, so I worked on the lecture notes a little bit and then نمت على الكنبة الحقيقة, okay, from about 11:30 to 2, and then I woke up, worked on it وما نمت لبعد الفجر يعني excuse me if I'm not 100% focused today. By the way, I'm used to not sleeping a lot, but don't worry about me. So this basically is the signal x of t that I gave you, which consists of 2 parts that look like a rectangle and a triangle. The idea here is that it does not have any symmetric features, so that whenever something happens to that signal, it becomes clear to you what has happened. And I gave you x of t, and I'm asking you to find y of t or sketch y of t, which is equal to 5 minus 2 times x of minus 0.5 t plus 1. And last class, I remember I started doing the transformation step by step, and I told you that at least for the time transformations, I'll do them in two ways. For the amplitude transformations, they're quite simple, so you can do them without confusion, hopefully. But for the time transformation, you have to pay attention to a couple of things that I'm going to mention. Okay? Now, when you come to a signal like this, or when you want to sketch a signal that looks like this, okay, in terms of x, you have to pay attention to. Let's start with the time, and then we'll work with the amplitude. Yes.
دكتور عدنان بس صوت المروحة. صوت المروحة
ما عندي مروحة.
في فويس مرة مزعج.
Really?
أتوقع.
Everybody hears that?
Yes, doctor.
But I'll do something. Maybe it's because of my mobile phone. I'll see if you still hear it now?
Yes. تو طالع قبل شوي. قبل دقيقة.
والله I don't know. ما تغير عليه شيء حقيقة. I'm still in the same room and nothing has changed at all. طيب. I don't know. You still hear it,
no,
right?
No, perfect. That's clean.
Okay. Okay. Please let me know if still you have any problem with the voice or so. Let me know, and inshallah, I'll try to do something. Hopefully, it will go over. Right. So we were talking about the time transformation. Whenever you have the argument of a function that looks like this, something multiplies t added to it something. Okay. There's always 2 ways for solving or for sketching a signal. What I'm going to do at the beginning is I'm going to try to sketch the following. T plus 1. Okay. And then we'll see what to do with those 2 things there. Okay. So if you want to sketch this in terms of x of t, there are 2 ways of doing it. One of them is you start with the shift. Clearly, the one there will cause a time shift. Okay? You start with the shift and then go to the scaling and possibly the time reversal. The other way is you start with the time reversal and the time scaling, and then you go to the shift. And by the way, the solution for both cases exists below. Right? And I'll show you that both of them give you the same answer. Right? Okay, if we wanted to start with the shift, what should you do? Go and sketch the following: x of t plus 1. We are starting with x of t. So we're going to go step by step until we reach this. And to be able to go from x of t to this thing, you'll have generally to go over 2 steps or 3 steps. Right? If I'm going to start with the time shift, sketch a signal that has the time shift, which is basically equal to 1 in this situation. Okay, so go first step. Let's say the first step that you're going to do is try to transform your signal from x of t to go to x of t plus 1. Right? The next step will be to include the time reversal, where you will remove every t and replace it with minus t, and you'll see what is the effect of that. And the third step is to do the time scaling, where you're going to remove every t and replace it with a scaled version of t. Okay? So let me show you basically the solution. And the reason why I put the solution there is that I wanted to save time. I didn't want to do the sketching. So this is x of t that I have. If someone asks you, can you tell me what is x of t plus 1 going to be equal to? Anybody can answer me? What is x of t plus 1? What is the thing that I have to do to x of t to come up or to get x of t plus 1? Okay, some of you have raised your hands. Jihad.
Yes, doctor. Shift it to the left.
Left or right?
One left.
What? But this is a plus.
Yeah, but on the time scale we put the rule is t minus t naught.
You're right. I was just trying to trick you, maybe. Okay. You're
Yeah,
absolutely right. Okay. So basically, okay. Okay. So basically, adding 1 to the argument there, having t plus 1 instead of t, will result in shifting this by 1 unit to the left. So clearly, the 2 will come to the 1. This point will come to minus 1, and this point will go to minus 4, right? And this is basically what you're supposed to do. Or this is basically what you're gonna get. Okay. Sorry. What did I do in here? Okay, I have the other method. Sorry, let me switch down. Yeah. Okay. Sorry, I started with the other method. As I mentioned, I have the 2 methods there. So I started discussing the other method, not the first method. Okay. So hold on. Sorry. This, by the way, I made some mistakes yesterday and I corrected them. This should have been plus. I mean, what I have below is correct, but in here this should have been plus. Okay, so my apologies. Okay, so this should be left in here. Okay, by 1 unit. Right? But look, what I have sketched there is accurate. It's correct. It's just that the text that I have above is not correct. Okay, so I have done the shifting. Now I need to go 1 step further. What does that step further do? I'm doing in here the time compression or time expansion. Let's say the time scaling. Right? And then at the last stage will be the time reversal. Okay. So what are we doing here? Think of this signal as z of t. Okay. We want now not to sketch z of t, but we want to sketch a scaled version of time with respect to z of t. We want to sketch z of 0.5 t. If z of t is equal to x of t plus 1, then what is z of 0.5 t? Wherever you see t, remove it and replace it with 0.5 t. Isn't this going to give us x of 0.5 t plus 1 or not? It is, isn't it? So now what I need to do is I need to think of this as another function. I'll call it z of t, which looks like this. And I'm interested in sketching z of 0.5 t. Forget about x of t now completely. Now I've reached a point where I'm talking about another function which is called z of t. Clearly, because I'm multiplying t by a value that is 0.5, which means that I'm expanding by a factor of 2. Or you can think of z of t here, you can think of the function that I want to sketch as z of t divided by 2. So I am expanding by a factor that is equal to 2. So every point now will go to double its value. The point that is at 1 will come to 2. The point that is at minus 1 will go to minus 2. The point that is at minus 3 will go to minus 6. Okay? And by doing this, I'll get z of 0.5t, which is equal to x of 0.5t plus 1. And I'll end up with this function now. Now think of this as w of t. What is the last thing that I have to do? Every t, I have to replace it with minus t. So I want now to sketch w of minus t. Because w of minus t, when I remove every t in here and replace it with minus t, I'll end up with x of minus 0.5 t plus 1. Okay? And this basically, this is exactly what I wanted to sketch. If you know, look above and there, this is exactly what I wanted to sketch in here. Minus 0.5 t plus 1. So I have done the transformations in 3 steps. Okay. Now the last step, doing this, or basically replacing every t with minus t, will make this function flip not around the, for example, the original point that was there. No, around the y-axis. Remember that removing t and replacing it with minus t flips whatever function you have in front of you around the y-axis. This is the y-axis there. So I'll get the mirror image of that function around the y-axis. So clearly this will come in there, this will come in here, and all of this will go in there. And this is basically what I will get. Just to show you that this is exactly what I will get. Okay, so this is in fact x of minus 0.5 t plus 1. So I have done one of the two methods for doing the time transformations. Now let me go to the other method for doing the time transformations, which is thinking of the time shifts, or basically the time shift will happen at the end. Okay? It will be a mistake if you did this. This is, by the way, I have seen this in previous times that I've taught this course or other courses in which I have to, the part of the course was about this material. I have seen people who will do, let's say, a mistake that I'm going to talk about in a minute. Okay. Now, if you want to leave the time shift to the end, this is what you need to do. You need to look at your signal that you want to sketch, which is this. And you have to represent it such that the time shift appears, or the amount of the time shift will appear as a value that is either subtracted or added to t, not subtracted or added to 0.5t or minus 0.5t or something like that. Meaning you have to write this in a way where it will be something like the following: 5 minus 2x, and then you'll come to what's inside in here and try to take everything that is multiplying t as a common factor from everything that is inside. So I'll write in here minus 0.5, open brackets, let's say, and put in there t. Now for this to be the same as this, what should I add in here or subtract? If I have minus 0.5 multiplying t, I'll get minus 0.5 t. Let me answer it. I think probably all of you will be able to get it. Thank you so much for volunteering to answer. But let me just do it in here, and maybe I can ask you to answer other questions. Okay. So minus 0.5 multiplied by t. I have to put something in there that if I multiply it by the minus 0.5, I get the 1. Or basically think of it this way: take a minus 0.5 as common factor out of the 1. So clearly I will have to have minus 2 in there. Yeah. And just to make sure that this is accurate, just open the parentheses there. I'll end up with minus 0.5 t. Okay. And the minus 0.5 multiplied by minus 2 will give me plus 1. So I'll end up with the same thing. So now, in fact, the three steps that I'm going to apply to this function will go the following. I'll do the time reversal. I'll do the time scaling, let's say. And then at the end, I'll do the time shift. If you make the time shift based on a value that is equal to 1, you get the wrong answer. The time shift, as you see, would be equal to 2 units, even in the opposite direction. Right? Let me do it, and then you'll see that both of those two answers will give me the same answer. Or both of those two methods will give me the same answer. So I'm starting with x of t. I'm doing the time reversal first, which means I think I'm doing the time reversal. Let me just remember. Yeah, time first, which means that I have to flip it around the y-axis as it is. I didn't shift it. I didn't do anything to it. So I just flipped it around the y-axis. So this is basically what I'm going to get. Now I need to add 0.5 in there. I need to add 0.5. And you said that adding 0.5 there means an expansion by a factor of 2. So I'll get exactly the same function, but it will look like this. Okay? And this is exactly what I got in here. Now comes the time shift. And it will be a big mistake if you looked at the time shift in here and said, the original signal has a time shift that is equal to 1. And it's 1 unit to the left because I have a positive here. So take this thing. Take this one and shift it 1 unit to the left. If you do this, that's wrong. Since the time shift comes at the end, you have to see, you want to replace every t with t minus 2. The minus 1 was just a value that we use to obtain how much is the time shift. But the time shift is not equal to 1, or let's say 1 unit to the left. It's in fact 2 units to the right. So now I have to take this thing and shift it 2 units to the right. So basically it will be like that. Which, if I'm not mistaken, it's exactly the same thing that I got. Okay, yeah, this is the final answer, and this should be exactly the same thing that I got from this. Okay, so now I have done basically the time transfer in 2 ways. You do it this way or that way, both are okay, but please pay attention when you're doing it. Please pay attention to what you're doing. Okay, now what remains is the amplitude transformation, and in the amplitude transformation, I forgot what the function was. It was, I think, 5 minus 2x. Okay? So clearly, I need to do amplitude reversal, which means that this thing will be flipped down, and then I have to scale it by a factor of 2, which means that instead of reaching a value of 6, it will reach a value of 12, of minus 12. First of all, time reversal. So now I have a minus 6 in here. Everything has been flipped around the x-axis. And then I scale it by a factor of 2, so the minus 6 will go to minus 12. And the last thing is I added to it 5. There's a plus 5 in there. So every value of the function will be raised up by a factor of 5. And this is what I'm doing in here. I have done the time reversal, the amplitude reversal. This is the amplitude scaling by a factor of 2. So I have minus 12 in here and minus 6 in there. And the last thing is adding 5 in there will result in everything being shifted up by 5 units, which will result in 4. Okay? So this is basically the final answer that I'm asked to find. Okay, Juan? Any questions? تفضل حسين.
في التايم شيفت لما نسوي حق المثلث لما يقطع الواي اكسس، كيف اعرف فين قطع الواي اكسس؟
Okay, you're talking about this one, for example. Okay. لا, sorry.
أول خطوة.
Okay, أول خطوة in which method? This, here, let's say this one.
Yes, the second one, step 3.
طيب. Okay. You're talking about how did I know that this is equal to 3, for example, right?
Yes.
Okay. This is not that difficult. Remember that this is a straight line, right? Straight line that starts at 0 here and ends at 6 in there. Or let's say it starts at 6 at one point and ends at 0 at the end. And at the same time, this line goes, let's say, or occupies the time interval between minus 4 and 0. And I'm shifting to the right by 2 units. So clearly the minus 4 will come to 2, minus 2, and the 0 will go to 2. So I'll end up with a line, think of it this way. I have a triangle, okay? And I'm interested in knowing what is the middle point here, because you see the middle point that was here at minus 2 will come at 0. And I'm interested now to know what is the height of this point. This point is basically the middle point between the peak and the bottom. If this is 6 and this is 0, this has to be at 3. If I had a shift, just maybe to add to what you just mentioned, if, for example, the shift was by 1 unit, not 2 units, but only 1 unit, for example, minus 1, okay, then in this situation, this is what will happen. Just zoom in, okay? I know that this point will come to 1. This point will go to minus 3. So clearly the point that will come over the 0 is the point that is at minus 1. So this is the point that will come in here. Now I have a triangle. This looks like a triangle or so. And forget about the triangle. I have a straight line. The straight line increases 6 units in 4 seconds. If I'm going in the opposite direction, or you can think of it as it decreases 6 units in 4 seconds if I'm going to the left, right? So I want to figure out if I start from this point and go to this point, how much will I drop? If I drop 6 units in 4 seconds, so in 3 seconds from here to here, I have 3 seconds. If I go to the right by 3 seconds, I will drop by 6 divided by 4, 6 divided by 4 multiplied by 3. Yeah, this is just what they call it, tanasub. Okay, I know that every 1 unit I drop by 1.5. which is the slope of that line. So 1 second in here, I drop by 1.5. Another second, I'll drop by another 1.5, which means that I'll be at 3. Another second, I'll be at 1.5. And the fourth second, I'll be at 0. Okay, did I answer your question?
Yes.
Okay. Any other questions, gentlemen?
Yes, Doctor.
Oh, yes.
Can we start with shifting the amplitude, then moving to the time shift?
Yes, you can. You can. It will be exactly the same, and in fact, it's not going to add more complexity or less complexity. It's just that you'll start instead of. Let me show you. You see the final version that I have in here. Okay, this is the final version. Yeah. Oh, sorry. I thought that this was Word. I cannot move it. Okay, but you see this figure. Okay, if you start with the amplitude, let's say transformations, and then go to the time transformations, you think of it this way. When you come to the original problem, what is x of t? This is the original problem, and instead of starting with x of t, okay, you start with a function that looks like I forgot what that function was looked like. It was I think inversed at the bottom. Something like this. I don't remember honestly the shape of it, but think of it as you'll start with the amplitude transformation, so you'll come up with something that looks like this. I'm sorry, not even like that. It will be exactly like this, because there's no time shift. Okay, something like this, but maybe scaled more and shifted up, and then you apply the time transformations on this one rather than this one, and you should come up exactly with the same answer. Guaranteed, 100%.
And
Okay,
is there a way to ensure the accuracy of my shift or my graph?
what do you mean the accuracy?
يعني لو سويت الشيفت في الامبليتيود في التايم كيف اتاكد ان بطريقه اتاكد ان الجراف اللي طلع معي في النهايه صحيح او لا؟
Okay, thank you so much. In fact, I wanted to mention this, but I forgot. Thank you so much for reminding me. Okay, like now you have done the transformation. Okay, completely, and you're thinking, well, maybe I have made a mistake. By the way, if you're in an exam, I would recommend that you just trust what you have done. And the reason why is that in exams, if you doubt sometimes your work, it wastes a lot of time from you, and you don't gain that much points. For example, if you solve this and at the final answer, for example, you came here and instead of showing me this, you showed me something that is shifted by 1 unit. For example, something like this. Maybe I'll sketch it in green or so. You showed me something that looks like this. Okay, probably you'll get 80% of the mark. Right? However, if you figured out that you had a mistake and you couldn't figure out where the mistake is, and you spent half an hour, right, trying to correct that, maybe if you're able to correct it, you're going to get that 2 marks added. But you might waste half an hour, an amount of time that is equal to half an hour that you could have solved a completely new problem. So my recommendation in an exam, if you're done and you have nothing to do, yes, go and check. But it doesn't make sense in the middle of the exam to go and check your answers on different problems, especially if the problem is very long. Because if you find that you have made a mistake, there's a big chance that you might even make more mistakes now because you get confused and you think that you're running out of time and so on. Okay? But let's say that you have all the time in the world and you want to make sure that you answer this question correctly. How can you verify that it is correct? I'll show you how you can verify. Let's come to that problem, okay? To the original problem. This is what you need to do. Let me erase everything in here. Go and select 2 or 3 points in your graph that are, let's say, key points. What do I mean by key points? Do not select, for example, this point of the graph or this point. Those are zeros. They don't mean anything. Okay? But select, for example, a point that is somewhere in here. For example, a point that is just after 3. For example, just to the right of 3, minus 2.9. and select maybe another point. For example, this point in here. Okay, which is just before 2. For example, 1.9. Okay? Now, how much is this function at the x of t? How much is it at minus 2.9? It's equal to minus 3, صح? Which means x of t at, let's say x of, let me write it this way. X of minus 2.9, how much is it? It's equal to 3. Okay, and how much is x of 1.9? I'm not going to use a calculator, but roughly speaking, it's going to be equal to approximately 5.8 maybe, or something like this, right? It's just less than 6, isn't it? Okay, so 5.8. Okay. Now, you have sketched y of t. Okay. What I would suggest to you is go and plug in the values of, let me see, of t. Let me see how you can do it. Let's see. I just want to make sure that I get it right. Okay, if you plug in here. Okay, I think I have done it. My apologies. I have done it in the opposite way. I should have taken maybe values from y. My apologies. I think this will give me better. Yeah. Come in here. Okay. Yeah. Take this is y of t. It's equal to this. Okay. Take 2 points. Take this point again. And take this point, for example. 2 points, 3 points if you have a lot of time. Okay. And figure out this point is minus 1.9. And this point, for example, is 5.9. Okay. Now, based on this, y at minus 1, y at minus 1.9 is equal to approximately minus 6.8 maybe, or something like this. Okay. And y at 5.9 is approximately equal to minus, or in fact equal to minus 1. Okay. Now let me take those two values and copy them and move them up. Okay, Control X, and let me move up to the original function. Okay, in here. What did I do? I hope I didn't mess up things. Right, I know. Okay, this is the, yeah, okay. So this is basically, those are the values of y at 2 points. Okay. Now, theoretically, if you plug in this in here, if I plug in 1.9 in there, okay, okay, let me take the 1.9 and plug it there. Okay. So y of minus 1.9, based on the relationship between y and x, what should I get? This should be equal to 5 minus 2. Let me write it to the side. Y of minus 1.9 should be equal to 5 minus 2 multiplied by x evaluated at minus 0.5. And every t now that you see in there, replace it with minus 1.9. Minus 0.5 multiplied by minus 1.9 added to it 1. Let's see, how much is this equal to? Does it give me the same value, which is equal to minus 6.8 or not? Okay, so I have 5 minus 2 times x evaluated at how much? This is minus 0.5 multiplied by 1.9. This is going to be slightly less than 2, right? Positive and slightly less than 2, isn't it? Approximately 1.8 or 1.9 or something like this. Right? Add to it 1. How much will I get? Hold on, let me see. Let me just make sure that I didn't do it wrong. 5. 0.5 times 1.9, or let's say 0.5 times 2, that's approximately 1. Yeah. 4. Sorry. So this thing is going to be just less than 1, approximately 0.95, for example. Right? When you add to it 1, you'll get this evaluated at x of 1.95, for example. Now let's see. In the original function x of t, if I evaluate at 1.95, how much do I get? I get approximately, let's say 5.8. In fact, this is approximately the value that I found there. So let me take this value and plug it in there and see, do I get the same value that I got from here or not? Numbers don't seem to make sense, but I hope that I have made a mistake in the calculations. Okay. X of 1. No, I think they're okay. If I take x at 1.9, it's 5.8. Plug it in there, so I'll get 5 minus 2 times 5.8, which will be equal to, this is approximately equal to, I mean, if you had a calculator, probably it will make it easier for you. This will be approximately equal to minus 11.7 or something like this. 5 minus 11.7 is going to be minus 12, minus 7.7, I think.
Minus 6.
Right?
Minus 6.6.
Okay, yeah, thank you so much for it. Okay, so basically, if you notice, I was not accurate. I was not taking the values accurately, okay? But what I'm saying is that, gentlemen, this is what you're supposed to do. Go to the final answer that you have, the final curve that you have, and take 2 points, 2 or 3 points. The more points you take, the better, okay? But I think that probably 1 point is more than enough. Evaluate that point in the function, in the curve that you found, and then go to the original definition of that function and plug at that time that you have selected, plug in at that time what time you selected, and find what is y of t based on x of t from that formula. If you get the same answer, this most likely means that the solution that you have got is correct. If you get something that is completely wrong, this means that you're probably you have made a mistake. And by the way, one simple mistake, either in time shift or in amplitude shift or in any of those, will completely produce to you most likely a completely different answer. I mean, it's not just going to produce to you, for example, 3.3 compared to 3.2. You see that the answer that you're searching for is 8, while the answer that you got is minus 4.5. Okay, gentlemen? So I hope that I have kind of clarified the idea for you so that you can at least do some check that will allow you to verify whether your answer is correct or not. Okay? So we spent almost more than half an hour on this, although I wanted to go further, but it's okay. You see, this material is kind of foundation, so if you understand it, it will help you later. So I'll stop discussing the transformations. Now let's talk about what we call signal characteristics. There are some features that exist in signals that are very, let's say, famous features or very famous characteristics in specific signals. Okay, one of the famous characteristics of signals is whether they are what we call odd signals or even signals. Now you may say, well, I know that numbers can be even or odd. 2 is an even number, 6 is an even number, 3 is an odd number. How can I have a signal that is even or odd? The concept is kind of taken from even and odd numbers, okay? Although it's applied in a completely different concept, okay? Any signal in the world will either be an even function or an even signal, or it will be an odd signal, or it will be neither. Now you see that signals that are neither even nor odd can always be represented as the sum of even signals and odd signals. For example, if I give you, as you see, inshallah, in a few minutes, once we discuss what is the meaning of an even function and what is the meaning of an odd function, any function that is, or any signal that is not an even signal and not an odd signal, I can always do a process to represent that signal as the sum of one even signal and one odd signal. Now, what's the definition of an even signal? And usually we abbreviate it or we write it as XE of t. An even signal is a signal that is symmetric around the y-axis, meaning that if you put a mirror on the y-axis, if you put a mirror, whatever is to the left will also be to the right. Exactly the same. Mirror image. This is basically the definition of an even signal. Okay? Think of it this way. Even numbers, why are they even? Because you can always divide them into two halves, صح? One half you put it on the right, and one half you put it on the left, for example. So a signal that is even has two halves that are exactly equal to each other, let's say, or exactly similar to each other. The part that is to the right is exactly similar to the part that is to the left. This is basically the definition of an even function. Now, how can you tell mathematically if a function is even? Anybody knows? If I told you, if I gave you x of t, if I told you, for example, that the x that I have above is an even function, okay? Can you do some, let's say, relation? Can you have some relationship that will tell you whether this is an even function or odd? MashaAllah, a lot of you. I'll just pick one of you by random. Iyad.
You substitute a t minus t for t and see if the
Absolutely.
equation is the same.
Exactly. Okay. If you have any function, any signal, and you find, thank you so much, gentlemen. By the way, next time, maybe to encourage you even to raise your hands, maybe I'll write, I don't know who raised their hands and who didn't. Okay. So maybe I can give you credit for this. In fact, by the way, part of the course is the participation. So later on, inshallah, I'll start asking, probably starting from next week, I'll start asking individual people. Yeah, Flan, can you answer me on this? And I don't mind if you give me an answer that is wrong. And the participation does not mean that you have to give me a correct answer to get the mark for the participation. Just give me a reasonable answer, something that indicates that you have thought about the question. Okay? A function or a signal that is even will always satisfy the following. If x of t is equal to x of minus t, then it is an even function. Okay? Meaning that if you flip the function around the y-axis, remember that we said that this is time reversal. This is a reversed form of x of t. If you reverse the function around the y-axis and you get exactly the same function, then that function or that signal is an even function. Okay? Based on this, can anyone guess what an odd function then is equal to? Is it a function where I can have something in here and, for example, something less on the other side? Because odd numbers, if I split them into two halves, I have, for example, 3 on one side and 2 on the other side. Fadal, Ibrahim.
When x of minus t equal to minus x of t.
Absolutely right. Yes. Okay. So what Ibrahim mentioned is absolutely right. What he said is this. This is the, let's say, the condition for a function to be even. For a function to be odd, it's almost the same, except that you have a minus sign there. So it's not enough. If you flip a function around the y-axis and you get exactly the same, this becomes even. But if you flip a function or a signal around the y-axis and you don't get the same, but you have also to flip it around the x-axis to get the same, then it becomes an odd function. Even functions will always look like this. For example, I can maybe sketch. Okay. This is an even function. Okay. Whatever you have to the right is similar to whatever you have to the left. An odd function, on the other hand, will always look like this. Not necessarily, I don't mean that it always has a triangle and a rectangle, but I'm talking about the feature in the odd function that makes it odd. If you look on the, let's say, left-hand side, you have exactly like this, but not in this form. It's flipped downwards. So basically, it will look like this. So remove this here. So this is how, oh, sorry, I messed up things. So this is how an odd function looks like. Okay? Fadal, right? You have a question maybe? Or?
With the origin, Doctor, right?
Say again, sorry?
With the origin, I mean. It's,
yes, it's symmetry around the origin. Yes, you're absolutely right. Okay. In fact, as Ra said, I was not thinking of saying this. Okay, but since you mentioned it, thank you so much. Every point basically is reflected around the origin to the corresponding point. Yes, you're absolutely right. Okay, and if you sketch a line from a point through the origin and extend it by the same amount, you'll hit the point on the other side. Okay. So this is basically the definition of even functions and odd functions. Now I mentioned that any function that is not even and not odd can always be represented as the sum of an even function and an odd function. Okay? So let's say, for example, that I gave you the following. And inshallah, I'll add a question or an exercise for you about this topic, inshallah, when I reach this point in the lecture notes. Assume that I told you that I have a function which looks like this, for example. Let me just think of a good answer, a good question. Is this even? Clearly not. Is it odd? Again, it's not. But I can always represent this function as the sum of two functions, one even and one odd. Okay? What is the formula? And I'm not going to do the exercise now. I'll just mention it. Okay? And as I mentioned, I'll add, inshallah, an exercise in the lecture notes that will hopefully clear this for you. Okay? But this is basically what you need to do. If you take this thing and flip it, this is what you'll have. Sorry, the opposite. So I flipped it around the y-axis. Okay? Add the two together. Okay? So if I add the two, what do you do when you add the two? You add point by point. So in here I have 0 added to 0, 0 added to 0, 0 added to 0, 0 added to 0. Okay? From here, for example, sorry, my plot is not that accurate, but from this point to this point, I am adding 0 in here from this, okay, with this part. When you add 0 with any function, you end up with only that function. So I'll end up in here with that part. Now for the rest, from here, let's say, until here, this is basically the part that I'm interested in. For this region, I'm adding this with that. So what will happen? Again, you're adding point to point. So you'll end up with something that looks like this. Okay? On the other hand, on the other side, you'll get exactly the opposite. Meaning you're adding this with this part in here. So you'll end up with something that looks like this. And then there's a small part in here that is not added to anything from there. So you'll end up with this. You know what I've just sketched? This is x even of t. If this is x of t, and this is x of minus t, the even part of that signal, x of t, is a signal that is obtained by adding x of t with its time reversed form. Okay? So this is the even function. Now the odd function, it's almost the same concept, but you don't add x of t with x of minus t. You add it, or you add it, or you subtract it from. You subtract x of minus t from it. Or think of it this way: you add x of t with the minus x of minus t. So you take this thing, flip it down like that. Okay, so remove this, and now add this thing with this. Whatever the shape of it, I'm not going to worry about it. Okay, but whatever the shape of this will be, will become the odd part. And the odd part has to be odd. It has to have a shape that will look probably, I'm not sure how it will look like. Something like this. I'm not sure. Maybe I'm not sure, but I think it's going to be something like this. Okay, when you add those two together. Right? So this becomes x odd of t. Now trust me on this. Maybe you cannot see it, but if you add, sorry, I forgot to mention something. After you add those two, you have to divide by 2. Divide by 2. Sorry for that. Okay. So add those two, and then divide 1 or multiply by 1/2. And the same thing for the odd. After you add x of t with minus x of minus t, you also have to divide by 2. So, sorry, I forgot the minus 2, the 1/2 there. Okay. But once you do this, you get x odd and x even. Trust me on this. Do you know what will happen if you add both of them? You'll get exactly x of t. And by the way, if you subtract them, you'll get x of minus t. Okay? So this is basically the formula for getting the even component, or the even, let's say the even part of a signal that is not even or odd. And this is how you get the odd component of a signal that is not even and not odd. Okay? As you see in here, we're adding those two. And multiplying by 0.5. My apologies, the equation doesn't look nice because I just wrote it using Word, but inshallah later on I'll fix it, okay? And to get the odd component, you subtract those, or you add x of t with minus x of minus t, and then you also divide by 0.5. Now, if you add both of those, you can even see it from here. If I add x even with x odd, what will happen? I'll get 0.5 x of t and 0.5 x of t, so I'll get x of t. But what will happen to the other part, the x of minus t? This basically will cancel with this if you add this. And if you subtract x of xe minus xo, this basically will cancel, and you'll get x of minus. Okay? So this is basically how you can work with even functions and odd functions, or odd, even, and odd signals. So if I have about 10 minutes, I think it's enough at least to discuss this. Yeah, okay, so we're okay, we're not behind. So I want you to also understand this. Do not think of numbers when you're thinking of adding or subtracting even functions or even signals. When you add an even signal with an even signal, you'll always get even. Why? Because remember that the two signals are symmetric around the y-axis. So whatever you have to the right is similar to whatever you have to the left in both. So when you add, again, the addition of the two will have the right-hand side similar to the left-hand side. Okay? So this is straightforward. When you add an odd function with another odd function, you see, in numbers, when you add an odd number with an odd number, what do you get? You get even. But in signals, no, you get an odd. So this is why I'm saying forget about numbers. Even and odd functions are not exactly similar to even and odd numbers. Okay? Odd number plus odd number becomes even. However, an odd signal with an odd signal becomes odd. Why? Because one of them has something in here and the opposite of it there. And the other one also has something in here and something in there. If you add those, you'll get something in there that looks exactly similar to what you have in there, but look for it. Okay? So odd plus odd becomes odd. Now it happens that even plus odd, in real numbers, it's an odd number, right? 5 plus 4, for example, is equal to 9. So even plus odd is an odd. In signals, it's neither even nor odd. Right? And you can easily verify. In fact, what we just mentioned a minute ago, in here, when we talked about even, when we added those, this is an even function, and this is an odd function, we ended up with a function that is not odd, in which we intentionally did this process to guess what is the even component of it and what is the odd component of it. Because it was not even, it was not odd. Okay? By the way, if you apply this process in here, if you apply this process, if you try to get the even component of an even function and the odd component of an even function, let's say that we have even x, and we applied this, both of those. What do you expect you'll get for x even? Anybody can guess? Again, let me mention it so that I have an even function, a function that looks symmetric around the y-axis. But I didn't notice that it was even. I thought, let me go and find what is its even component and what is its odd component. So I applied those. What will the x even be? Fadal, Abdurrahman, you raised your hand first.
X even will be even and odd will be odd.
You didn't answer me. What you said is clearly the x even will be even and the x odd will be odd. But I want you to tell me what are those in terms of x. I don't know if you understood my point or not, Abdurrahman. Okay.
No, I don't.
No problem. Abdullah?
For the even will be the function itself.
Absolutely right, yes. If you try to find those two for an even function, you'll find that x even, okay, will simply be equal to x. What about x odd? Muhammad? Since you're the only one who's raising your hand.
0.
Yes, 0, absolutely right, yes. Okay? So think of it this way. An even function does not have any odd components in it. And the same thing applies. An odd function does not have any even components in it. So if you apply for an even function, x even will be equal to x, and x odd will be equal to 0. And the opposite is true. If this was odd, okay, x even will be equal to 0, and x odd will be equal to the function itself. Further better.
Yes, doctor. What about multiply by half? Where will begin?
Yeah. Okay. Okay. قصدك where will the 0.5 go? That's
Yes.
what you're saying?
Yes.
You see, the 0.5. I understand your point. You see, you're adding x of t with the inverse of it. Okay, and the inverse of it is nothing but x of t. We said it's even, isn't it? We started with an even function.
Yes, you're right.
Okay, so x of t and x of minus t both are exactly the same. So when you add them, you get 2x of t, which cancels with the 0.5. Okay. Right. Any other questions? Okay. So so we were. Sorry, I didn't hear you.
No, I said it's clear.
Okay, thank you. Right. So we understood those. Right? Now, in multiplication, I think it's easier. If you multiply even by even, clearly you get even, because the left-hand side and let's say the left-hand side is the same as the right-hand side for an even function, for both even functions. And when you multiply them, whatever numbers you have on the right will be exactly the same as the numbers that you have on the left. So basically, you get exactly the same. I mean, it will remain even. But this is maybe something that you need to understand. If you have an odd function and you multiply by another odd function, you always get even. Why? Because remember that, assume, for example, that one of them, I think I have this example. Okay, let's say, okay, let me very quickly, I only have about 3 minutes or 4 minutes. I think it's enough to mention this. Assume that I have one function here which looks like this, and another function which looks like this, and both of them are odd. So this looks like this, and this looks like this. Okay. Now, if you multiply the right-hand side, you're going to take each point and multiply by the corresponding point from the other. So you get a value here. Now, it happens that what you have on the other side is exactly the same, but it's negative of what you have to the right. But because you're multiplying negative with negative, or the signs are basically, yeah, you see, if this was positive, I'll get negative from here. And if the other one is also positive, I'll get also negative from here. So because I have negative from here and negative from there, when you multiply them, the negative sign disappears. So you'll end up with a value that is exactly the same value, but in the other side, if both of them were below, you'll get something that is above. So you'll end up with exactly the same as if you have multiplied the even function of this with the even function of that. I'm not sure that I explained this well, but because I have a minus sign from both signals, when I go to the other side, I have a minus sign in the first and a minus sign in the second. When you multiply those two signals, the minus signs basically disappear. So you end up with exactly what you got by multiplying those. You'll also get exactly the same value with the same sign on the other side. And this is why odd multiplied by odd will give you even. And by the same concept, even multiplied by odd will always give you odd. Okay? So what remains for us in this topic is just something that hopefully will not take us a lot, which is basically periodic signals. So we've talked about even and odd. Now, not now, I mean next class, inshallah, it will be time to talk about periodic signals. Okay, Afwan? So I think I'll stop at this point, but let me just mention something. If you go to the syllabus, it says that there is a quiz, I think, tomorrow. Right? I mentioned last class that I'm not going to give you a quiz tomorrow. Your quiz is going to be on Sunday, and the topic of the quiz will be this. I'll probably give you problems or a question similar to this. Okay. I'll give you a signal or a function or something like that. Okay, x of t, and ask you to sketch y of t. Maybe not necessarily all of those components will be there. Okay, But I will give you another, I'll give you a function x of t, and I'll ask you to sketch x of t minus 5, for example, or x of 3t minus 2, whatever. Okay? So you need to know all of those transformations. So this is going to be your quiz on Sunday. So, and the quiz will be most likely, I haven't decided on it yet, and I'll probably work on it in the weekend. I'll either give you multiple choice maybe question, okay, where you're going to select, I give you, for example, 4 or 5 different signals and tell you which of those is equal to this. Basically give you the sketch of a signal and then give you 4 or 5 sketches of signals and ask you which of those sketches is equal to this. Maybe I'll do it this way. And there's a possibility that I'll ask you to do it in writing, meaning you're going to write it or sketch it on a piece of paper, and then I'll ask you to upload it. So, I haven't decided yet, but anyway, whether it's this way or that way, I'll let you know, inshallah, by probably tomorrow or during the weekend, I'll let you know. And inshallah, I promise you, during the weekend, I'll create the WhatsApp group. My apologies, I didn't have time during the past few days. I'll create the WhatsApp group, which includes all 38 of us, 38 or 37 of us, inshallah, and you'll be able to communicate with me if you have any questions or so. You'll be able to communicate with me right away. And I promise you that, inshallah, before the start of the weekend, you'll have this material. And maybe even maybe several examples that are related to this topic also in the lecture notes. Or at least, if I cannot provide you with a lot of problems, at least I will maybe give you some examples and maybe show you the final answers or so, maybe even by sketch by hand, so that you can practice. Okay? Ahmed, you have a question?
Yes, if you don't mind, if you could explain to me what's the difference between function and signal.
Both are.
Okay. And,
typically, I'll tell you, function typically can be described as a sine or cosine or something like this. Signal could be anything. It could be random. It could be, okay? But if I say function or signal, I more or less mean the same.
And at least in this course, will be focused in the linear function, or we'll deal with all kinds of functions, such as trigonometric, hyperbolic, quadratic, cubic, and etc.
We will deal with many functions that you probably have not seen before. Okay, trust me. You see in this course some functions that you have not seen before. You're going to see the sinc. You're going to see. I'm not sure. I don't think you have seen the step function and the rect function and the impulse function. And there are several functions that are important in our course that you have most likely not seen before. Right?
Okay.
Any other questions or points? Okay, if you don't have any points, inshallah, I'll see you next class. By the way, if you need me or if you have questions, I'll be happy to communicate with you after maybe half an hour or so, because I have a meeting after 3 minutes, okay? So if you allow me, I'll have to leave now. And inshallah, after the meeting, I'll be available on Blackboard or on any other method. Just send me an email or so. I'll be happy to connect with you and explain to you anything that you have.
Thank you, Doc.
Have a good day. حياكم الله جميعا.